Hello, this is Mr. Wyrick. I'm here to talk to you today about lesson 12.6, the surface area and volume of spheres. These are a little bit tricky. It's harder to kind of see where the formula comes from. I mean, when you talk about squares, when you talk about rectangles, it's pretty easy to say, okay, we've got this many units this way, we've got this many units this way, it's going to be this much because we multiply that together to get that. And then with the circles, you know, you can kind of figure out the pi r squared if you really get into detail on why that is, and 2 pi r for the circumference. It's a lot easier to start talking about area and surface area when you have shapes like that. But if you find yourself later on in life, especially getting into architecture, and you're designing something that has a dome, that's going to be a hemisphere. So you're going to need to be able to know inner outer surface area, how much material you're going to need if you're doing that. So it's important that we go over this and we talk about spheres. You deal with spheres a lot more than you know, especially those of you that play any kind of sport, basketball, baseball. So it's important to know, maybe not this stuff, but stuff that's going to include this later on, so that you can figure out exactly what it is that you need to do. The first thing is, if you're dealing with surface area, if you unpeel this, and you'd have this red swatch here and the green one here, essentially, you know, you're talking about the area of like a circle that would fit here, this middle space here, and a circle that would fit here, and then same for the red. So they got those together and worked out a formula, and what it is 4 pi r squared. They do some different stuff in the book about talking about if you have the area reducing down to just the radius and then plugging that same thing in here, but I feel like that's a big waste of time because our area of a circle is pi r squared. So if they give you the area of, you know it goes exactly through that diameter, and we've got that circle, they give you the area of the circle, just multiply that by 4, and that should give you a pretty good idea of what your surface area is going to be. Understand, there's only total surface area when we're talking about spheres. Since it does not have a base on the top, bottom, or any side, it's just round all the way around, there's not a separate lateral surface area for this one. If they give you a hemisphere and ask you to find the surface area, it's actually just going to be 3 of these. 2 for the half of the circle up on the top, and then of course the circle that you would have on the bottom would be pi r squared. So make sure you're careful with that one. They do talk a little bit about some planes intersecting a circle. Planes can intersect a circle anywhere. So if you have a plane that intersects a circle, if it includes the center of the sphere, which would be the center of any circle that you could cut from this really, that is a great circle. Okay? And then the poles are what we name the endpoints of any diameter. They're pretty specific when you're talking about the globe. We've got the North Pole, the South Pole, but that's not exactly what we're talking about here. A diameter can go from any direction. A sphere is one of those things where it's how many faces does it have? Infinite, because it's circular. So in this case, there are infinite number of diameters that could go through here, as long as they go from one point on the sphere to another point on the sphere and include that center. So there's a lot of different directions they can go, but it doesn't change what you have to do. When you're dealing with volume, it's going to be 4/3 pi times the radius cubed. And again, you can look in your book, you can look online, you can find the history of how they came up with this, or you can just accept it to be true, use the formula, remember the formula, and move forward from there. A lot of the problems that you're going to work on today are going to be ones where they give you some kind of measurement like diameter, area of a great circle going through it, something like that, and you're going to have to kind of reduce down to the radius and then work your way through it. The problems that I would like you to work today, let's do 10 through 44. 10 through 44. I'm not going to include some of the higher order thinking problems for this one. It's going to be enough, I think, to to keep reducing down to that radius that's going to keep you busy for quite some time. So we'll work problems 10 through 44 on this one. If you'd like some further explanation about spheres, or there's something on there that you just don't understand, something that I said that you didn't get, make sure come in tutorials, come ask questions, raise your hand during class, whatever it is, bring it to my attention and I'll try to help you go over that. And other than that, we will talk to you later. We'll see you in class.